All right, this next one is an exponential graph that I went ahead and typed into Desmos so we can go ahead and get started. So I got 3 times 2 to the x power minus 2. I go ahead and open Desmos up, and you can see I already typed that in. I'm going to zoom out just a little bit so we can kind of see everything that's going on. So the first question was, what is the y-intercept? The y-intercept, I'm just going to go zoom in just a little bit. So the y-intercept here is 0, 1. Let me go back. 0, 1. Is it growth or decay? And I can tell it is growth because it's going up at this shape. If it was going down like this, that would be decay. So it is growth. It has an asymptote, and remember the asymptote is wherever it looks like it's getting closer and closer to that number, but it's never actually going to hit that number. So it looks like for us that number is going to be -2. So it's getting closer and closer to -2, but it never actually touches -2. So your asymptote is -2. You can even say x equals -2, I guess. But let's just say -2. And then your range is whatever your asymptote is to positive or negative infinity. So it's going to be -2 to positive infinity in this case, because if I pull that back up, it's going from -2. Zoom out, please. Okay, what is wrong with this thing? I may have overloaded my iPad. There we go. And it just continues going up and up and up forever. All right. So then moving on to rational or irrational. The square root of 25 is 5, so I know that that one is rational because it's a perfect square. Pi plus 3 is going to be irrational because anytime you have pi plus something, it's just going to be irrational because pi is irrational. The square root of 10 minus 2, let's go ahead and open up the scientific calculator for this one. So the square root of 10, which is irrational because it's a non-perfect square, minus 2, and that's going to give me an irrational number. If it can be written as a fraction like 2/5, that makes it rational. If it's a repeating decimal, that's rational. And let's see if the square root of 2 times the square root of 18 gives me a rational number. So square root of 2, which is an irrational number, times the square root of 18, which is also an irrational number, works out to the square root of 36, which is a perfect square. So that one is rational. So sometimes you do have to try them. So even though these two individually are irrational, together they make a rational number. All right, this one says, I want standard to slope intercept. Slope intercept is y equals mx plus b. So what I want is that y by itself. So I'm going to start by subtracting by 3x. So that gets rid of that, leaves me 2y equals -3x plus 18. I'm going to divide by 2 because I'm still just trying to isolate y. So y equals -3 over 2x, and 18 divided by 2 is positive 9. And you can put this and this both in Desmos, and they should give you the same line. All right, this one, again, I'm trying to get y by itself, so I'm going to add 4x to both sides. So that cancels and leaves me 2y equals 4x minus 20. I'm going to divide by 2. It gives me y equals 2x minus 10. And again, if you put this and this in Desmos, they'll give you the same line. All right, so they do a thing called slip and slide method. That is not something I taught you. It's not something I think is beneficial for you to learn. What we do is the X method, and it's basically the same thing, just in a slightly different shape. So I'm going to go ahead and do X method with these. So remember on the top, you do 2 times 3, which is 6, and this number goes on the bottom. So then I'm looking for two numbers that will multiply to give me 6, but add to give me 5. So those two numbers are going to be 3 and 2. And because I had this coefficient up here, I'm going to divide. So what I've got is this one won't simplify, so it's going to be 2x plus 3 as one of mine, and this one will simplify, so it's going to give me x plus 1. So what I've got is 2x plus 3 times x plus 1, and if you put this and this in the calculator, they'll give you the same parabola. Same thing here, I'm just going to do x method. So 6 times -4 is -24, -5 goes on the bottom. So I need two numbers that will multiply to give me -24, but add to give me -5. And that is going to be, let's see, -8 and +3. Yeah, that works. -8, +3. I'm going to divide by the 6. And even though these won't necessarily divide into a whole number, they will simplify, so you do have to simplify. So 3/6 will simplify to, let's see, they'll both have 3, so that would simplify to 1/2. 8 and 6 can both be divided by 2, so -8 divided by 2 is -4, and 6 divided by 2 is 3. So then you take this and you go 2x plus 1. You take this and you go 3x minus 4. And again, if you put this in the calculator and this in the calculator, it'll give you the same parabola. So then I'm looking here for linear or nonlinear. And I can look at these and tell that they're linear or nonlinear. But if you cannot, it is so fine to just open up Desmos and type those in and see if they give you a straight line or not. Because if they don't give you a straight line, then they're not linear. So let me open up. I need graphic. Okay, so that's what I needed. All right, so let's go ahead and type in, I know that 2x minus 3 is because it's in the correct form. So that one, let me hit the home button. That one gave me a straight line, so that one's linear. You can probably tell that the next one isn't because you're familiar with parabolas and how they have to have that squared to make them a parabola, but you can tell that that one's nonlinear. All right, let's go on to the next one. You may not be able to look at this one, but that is actually standard form of a linear equation. So I know it's going to be a straight line. I just have to make sure. So that one's linear. And then the last one, you have to be really careful about how you type this one in, because if you don't get it in exactly right, it may do some weird stuff for you and not show you exactly what it needs. And you can tell that is fully not linear. It's actually some weird thing you'll learn about later. So that one's nonlinear. And then you're done with that section. So let's close Desmos maybe. There we go. All right, arithmetic sequences, and they gave you your needed formula. So this one, it looks like I'm gonna add 3 every time. 7 plus 3 is 11. No, 7, sorry, plus 4 is 11. 11 plus 4 is 15. 15 plus 4 is 19. So my difference each time is +4. A sub 1 is, remember, your first term. So in this case, it's 7. And then n is just whatever number they're looking for. So in this case, you're going to leave it when you're writing the formula. So a sub n equals a sub 1, which is 7, plus the difference, which is 4, times n minus 1. And then you're done with the explicit formula. But however, it asks you to find a sub 52. So a sub 52 equals 7 plus 4 times, and because it's asking for 52, you're going to put 52 in right here, minus 1, and then I'm just going to open up Desmos so you can see my calculator. Hit enter, and that was 7 plus 4 times 52 minus 1, which gives me 211. And then you're done with that. All right, exponential growth and decay. Mark buys $1,000 worth of stock in a company. He expects the value of the stock to increase. So I'm looking at growth, if I'm looking at increasing, by 5% each year. Remember that if you're writing 5%, that's really the decimal 0.05. So equals 5%. So remember, you can't write percent like as a whole number in these equations. You have to change them into a decimal. Write the function that models the scenario and find out how much the stock will be worth in 30 years. So that A that's right here is always your principal number, which in this case is 1,000, times 1 plus, and it's plus because he's expecting an increase. If it was a decrease, it would be a minus. The percent was 5%, but in this case, we're going to put 0.05 to the T. But in this case, they actually gave you a number of years, so it's going to be 30. So I can open up Desmos and put that in. Got 1,000 times 1 plus 0.05 to the 30th power, which gives me about $4,321.94. So simple enough for that. All right, multiplying binomials and trinomials wasn't something we had to cover in the standards, but it's pretty similar to FOILing. Instead of first, outer, inner, last, just everything that's in your first set of parentheses has to be multiplied by your second set of parentheses. So I'm going to start with a different color. So I'm going to go with maybe like this orangey color right here and do the 3x that's right here times everything in the second set of parentheses. So 3x times x squared. They don't have a coefficient, so I'm just going to bring the 3 down. X times x squared is x cubed. Okay, actually, let's not do that. 3x times negative 2x, so 3 times negative 2 is negative 6. X times x is x squared. And then 3x times 5. 3 times 5 is 15, and then they don't have any x's in common, so it's just going to be x. So now I am done with that 3x. I'm going to swap colors to do the negative 7. So now I have the negative 7 times x squared. So negative 7 times x squared is negative 7x squared. I have negative 7 times negative 2, which is positive 14x. And negative 7 times 5 is negative 7 times 5 is negative 35. Sorry. Then you just clean this up and you combine the like terms. So let me grab a different color for that also. So I've got 3x cubed. I don't have any other x cubes, so I'm just going to say 3x cubed. I've got negative 6x squared and negative 7x squared. I can combine those because they have the same variable and exponent term. So negative 6 and negative 7 make negative 13x squared. I've got 15x and positive 14x, and that's going to give me positive 29x. And then I've just got negative 35, and then you're done with that. I'm going to change the color just because this is a little bit hard to see. Why not just pick that one? Okay. So slope of a line, and then they gave you the equation for finding the slope of a line, which is y2 minus y1 over x2 minus x1. So this is x1 and y1 and x2 and y2. So I'm going to go ahead and set that up. So y2 would be 8 minus y1 is negative 4. I'm going to go ahead and clean that up. And then x2 is negative 9 minus x1 is positive 3. So 8 plus 4 is 12, and negative 9 minus 3 is negative 12, which is going to simplify to just a slope of negative 1. All right, we're done with that page.